All right. Good morning, good afternoon, wherever you may be joining from. My name is Caroline Coons, and I'm with Wavefront, and I'm going to take care of a couple quick housekeeping items for us this morning before we get going. First of all, note that we will be recording this webinar, and we will make it available to those of you who are registered. After this call, we will send that out in an email tomorrow. Second item to note is that this session will end with a Q&A. So after the presentation and the demo, we will be using the chat box feature to answer your questions. So if at any point during the presentation you have a question, just type it in the chat box and it'll send a message to the panelists, and we'll try and answer as many of those as we can. So with that, I'm going to hand things off to Howard Yu, who is a systems engineer at Wavefront.
Thank you, Caroline, and good morning, everybody. How are you all doing? Good to be here, and just to give you a little bit of an introduction to myself, my name is Howard Yu, and I work as a systems engineer in Wavefront team, and I mainly do a lot of the customer engagements and proof of concepts, and also some of the enablements on the Wavefront related technologies and best practice. So it's certainly great to be here, and today I'll be presenting you about a couple of things about Wavefront, what that is. So Wavefront is a SaaS-based metrics monitoring platform, and it's completely provided as a service running on top of a cloud being hosted by the Wavefront team. And it is aiming to solve some of the problems that are getting bigger and bigger, the monitoring challenges of the modern application developments. Today's applications are very flexible, and it gives developers and the users both a unprecedented scalability, ease of maintenance, automations, and all those cool things. However, because they are flexible and they move fast, it apparently inherently gives the monitoring challenges, because with the fast of the speed comes the complexity. The modern applications are not monolithic. They are distributed, and they are running sometimes in virtual, sometimes in cloud, in many different places, many different flavors, by many different people. So inherently, trying to look at them all at the same time becomes a great challenge. The great challenge also becomes really great when there's a culture of continuous delivery and continuous integration on the DevOps culture. A lot of the teams are very independent and very segregated to each other, yet they have to create something that moves in a single action, or that does process a single transactions as holistically. So because of those diversity and because of those speed of the change, trying to monitor something becomes really challenging, because you inherently get the lack of unified visibility. You typically will see that in your environment there are 5 or 6 different tools managed by 5 or 6 different each individual teams. They don't actively communicate to each other, and because of those, trying to look everything and move fast at the same time becomes a great hurdle. You have to see everything in order to be able to move fast with your deployment and with your development. So here comes the Wavefront. It's aiming to remove some of the monitoring challenges, real-time monitoring challenges, to be more precise, and give users or developers a self-serviceable analytics on top of it. What that means is that the users who are going to be developing their codes shouldn't have to worry about how their metrics monitoring solution is going to be operated, how their monitoring solution is going to get scaled or reliable or secured. They don't normally need to worry about that. Instead, they only need to focus on their development. And everything else, the monitoring needs is going to be provided as a service. Because it's a SaaS model, you get a simplicity in doing that. We will handle all the activities of your metrics monitoring, and then provide a good and flexible query language, as well as the advanced UIs for anybody, including the SREs, developers, or business users, or just any users within the organizations, to monitor whatever they want to monitor, query whatever they want to query, correlate, create alerts, and automate things, whatever they want to automate things using Wavefront. The Wavefront has some of the key differentiators. If you have a questions there are many different monitoring solutions out there, and they have their individual tastes and characteristics. If we could categorize Wavefront's advantages into 4 categories, these are as follows. It has the advanced query-driven analytics. So we have a query language that is very flexible to use. And it has a lot of analytics built into the query language so that you can use them within your query to perform many interesting correlations, anomaly detections, forecastings, and all the aggregated functions as well. One of the motivations of this query language came from some of the founders of Wavefront who used to work to monitor container technologies in companies like Google. They were getting frequently frustrated by the lack of features and flexibility in the monitoring. They could only monitor limited set of attributes or only a limited set of system attributes. It was really hard to customize some of those metrics monitoring. Hence, they invented this query language. The other one is the massive scalability and availability of our solution. It is generally hard and requires a huge amount of investment if you want to run a good monitoring solutions on-prem. You got to keep updating it to newer versions and fix bugs. But at the same time, you got to mind about the growing CPU consumptions and also growing storage requirements to contain all your metrics data. Wavefront, on the other hand, does that for you. So you don't really have to worry about tuning or optimizing or even sizing up your solutions. It does provide a massive scalable ways to scale up automatically as your ingestion goes up. And then it is highly available all the time. Our massive scalability can measure up to 5 million points per second. That's about 5 million ingestion points that happen every second can be ingested. And that's something that's not really easy for you to do yourself. And you don't necessarily want your developers to spend much of your time trying to optimize that. So that's one of the advantages of having a SaaS-based cloud metrics monitoring. The other one is a high customization and also shareable dashboards. We wanted people to collaborate and come to Wavefront to share some of their findings or some of their analytics without having to go somewhere else. Because Wavefront is designed to collect all the sources regardless of their stacks or technologies, and can visualizing all at the same time. This gives a user greater opportunities to visualize and customize according to their needs, but also at the same time share some of their findings very easily with other peers in their group. This will reduce a huge amount of communication that goes between each of the teams, and also facilitate the collaborative culture of looking at the problem and solving the problem all together. Lastly, we have a very intelligent alerting for proactive monitoring. So our alerts are very much like our query language, because it is actually based on our query language. You can create just about any alert types that you want, rather than being limited to certain alerts that are controlled by the system. You can create alerts for detecting whether your system is online or offline. That's very easy. 2, alerts on the trend of your data. Is the metrics going up or is the metrics going down? as well as more of an advanced AI-based alerting, such as anomaly detection. I'll be showing a little bit of an anomaly detection in my demo, but our aim is to make sure that all the anomalies can be detected quite easily using a simple expression in query language. And not only that, we have a forecasting functions that will make you even more proactive in monitoring, because it's gonna give you a forecast of your size demands or your billing requirements in the future. When we were designing the Wavefront, we wanted to make sure that the Wavefront can be as easy as possible in collecting all the metrics that your system has. It is actually one of the core things that you have to do if you want your product to be successful in a very diverse environment. You want to make sure that your door is as wide open as possible in collecting all the metrics. We do have a couple of different ways to ingest different types of metrics. Sometimes we can have an options to have agents or collecting agents that sits on top of each of the host environments or the systems, collecting the metrics locally and then send it over to a Wavefront proxy, which is gonna eventually get relayed into the Wavefront server. We sometimes would use the log files or the log files located in some shared directories where Wavefront proxy can crawl them, collect them, parse them, and send it to a Wavefront automatically. We can have metrics or application codes instrumentalizing the creation of the metrics. This is pretty useful when the application metrics are coming from a custom as a custom metrics representing their business performances, for example. In this case, we have a wide ways of providing instrumentation libraries or the libraries for you to use, and simply call the API calls to relay your metrics to the Wavefront server. And lastly, we have a direct API connectivity with some of the cloud environments that exposes the API endpoints to collect their metrics, such as the AWS CloudWatch. In that case, Wavefront will periodically query them and then ingest all their metrics without having you to install or run any agents or proxies. We also have a newer interface in our REST environment where the Wavefront can now receive data directly from each endpoint. So rather than agents sending the metrics, your application can now send the metrics directly to Wavefront if you choose to do so. So with that kind of 5 different ways to collect the metrics, we can cover pretty much most of the integration requirements given by the customers to easily and quickly integrate most of their systems into Wavefront. And if the customers do not have existing integrations, we can surely work with them to create a new one, as we have a dedicated development team that creates integrations for us. So speaking of the Wavefront integrations, we've been progressing really well for the last 1 year. Our integration team would push out about 20 to 25 integrations per quarter, and the number quickly grew up to right now close to 170 integrations. Whether the integration is from the applications or from the containers like Docker or Kubernetes, or just the traditional data stores like databases to host environments like Linux, virtual machines like VMwares, or DevOps tools, the web containers or web servers, alert notifications or messaging queues, monitoring tools to the cloud. All the spectrum of the metrics that you may want to monitor can be easily supported by Wavefront. Because inside our server, we actually do not differentiate all those metrics data. They are all coming in the same format, the Wavefront data format. And once they are ingested in our environment, we can query them and alert them using the same query language. So, and I'll be going through some of the integrations and how we would do it in our demo. But these are just to give you an idea that we have a rich set of integrations already already out of the box from the day one that you start using Wavefront. So what are some of the things that the customers say about Wavefront? A lot of the great things. Wavefront metrics is going to give them the ability to see everything. We have some use cases where customers who didn't used to see all their network activities happening on their switches and the servers at the same time were able to do that using our dashboard. They were able to pull the metrics happening from all their Linux boxes in their network devices, and at the same time, pull the same metrics happening from their firewalls and network switches. And by correlating those metrics together, they could easily see what kind of impact some of the Linux hosts were having in terms of their network ingestions and traffic control, giving them a better accurate view of what's happening, and also be able to quickly resolve some of the issues that they really didn't have a clue of when they tried to troubleshoot. Also, one customer use case is have a more than 20,000 containers. Having to manage all their metrics were kind of a pain for them because their metrics monitoring systems start to scale up as soon as they start using containers. They were spending more money than they anticipated in monitoring all those. By switching over to the SaaS solutions like Wavefront, it greatly enhanced not only their real-time monitoring capabilities, but also the cost reductions that they experienced. And lastly, just as the code says, the beauty of using Wavefront as opposed to the pointer silo tools is that my metrics and alerting all stay in the same place. That's real powerful. I only need one maintenance window, one Slack, one webhook, or one PagerDuty configuration in order to do monitoring on all my metrics. And that's a great testament to what the Wavefront is trying to do. It's trying to be a first pane of glass for all your metrics in a serviceable way. Now, I think I'll be jumping over to the demo and show some of the things that I've talked during the overview section of my presentation, and give you a better, maybe better look and feel of what the Wavefront in general can do you some good. So here, this is the first screen, or the integration screen of our UI. And we have four main components in our UI: the dashboards, which contains all the visualizations; the alerts contains all the alerts that you create; the integrations, where you will be working to hook up much of your systems to the Wavefront very easily; and the browse, where you will be able to browse many of the raw elements inside the Wavefront. As you can see in the integrations, all the integrations are nicely laid out as a tile format. And you could see some of the integrations tile that were mentioned in the slides, like web containers here. But more than them, kind of show you a nice, easy overlooking view of what you can collect using Wavefront out of the box. Now, I'm sure that many of you might have some questions about the tiles, but I will defer the questions later after the demo. I just wanted to demonstrate how we'll be able to easily integrate some of the systems on this tile page. So, for example, if you want to integrate AWS environment, you will simply click the tile and go to the setup screen. And then you'll see all your existing integrations. But if you want to set up a new Amazon integration, you just follow the simple instructions written on the right, which it's just getting the role's ID and giving the role a permission, and have it set up in our integration setup here, and just click the setup. And what it does is that it will start collecting all the CloudWatch metrics that's given to this role. And we have a couple of ones that are running right now here. Once you start, after you complete the integrations, you will go to the metrics page to monitor the flow of the metrics, some of the metrics that's happening. So in this page, you can kind of check quickly that the metrics is flowing and which rate. So this is the points per second rate that we are ingesting from the AWS service right now. In the dashboard is where all the UIs are actually residing. So after you go through the overview, the setup, the metrics, the next page will be the dashboard, where you'll be able to actually see each individual component, such as, for example, in this case, the EC2 instance, and see the real-time visibility of your data. And our dashboards would look something like this. And you will typically go, or the general users or casual users will typically go into these kind of a dashboards, or show that in their big monitor on a central room to quickly glance and check real-time operational status of all the EC2 related things that happen at the same time. And as you can see, you can scroll down, and you can see that all the data are kind of being kind of lazy loaded as you go down. So you don't really have to wait until all the pages are loaded. You can simply go and see as they get loaded. We have a new dashboard that is coming up, and it's currently on a beta feature. This new dashboard is even going to give you a greater experience as giving all the regions of the AWS on a single kind of a nice globe pane of a kind of a way. You can drill down to each individual kind of a regions, and then get to see the heat map of the EC2 instances, for example, that's happening on this West Region 2 in a very holistic way. So just quickly glance that there are some of the servers that are having a poor CPU, contrast to some of the good behaving CPUs. Can actually get a holistic view very quickly, and then drill down to some of the servers that has been exhibiting some problems. And you can see that quickly that the CPU has been climbing up since 9 a.m. Today. So this is some of the useful features in the dashboards of seeing a globe level from the outside of the space to quickly zoom into the very instance of the EC2 that shows the problem, and be able to communicate quickly with your peer groups to resolve the situation. Now, speaking of the dashboards, I'm actually going to move to some of the other advanced feature of the Wavefront, such as our query language. So all these user interfaces are basically being visualized by our query language. And let me show you some of the examples. This is a create chart page that shows a particular matrices. And as you can see in the bottom section where the query is defined, you see that we are using a TS as a main function to collect CPU load average on 1 minute interval metrics from a specific source called a cluster. This is an example of the query language that all our dashboards are being powered by. You don't necessarily need to learn all the query languages because you have the out-of-box dashboard already being pre-populated with all the necessary queries. But if you want to explore more deeper and analyze the matrices just the way you want, this will be your best friend in Wavefront. We have other useful features like Query Builder that will automatically do some of the queries for you. So you don't really have to worry too much about typing a lot of stuffs. Many of the things are automatically discovered as you type in the code. And I'm going to show you a couple of examples or how the query language can be used in order to perform some of the aggregations on the metrics data that you're seeing here. So let's say that these are all the CPU matrices happening on your cluster, and you want to quickly get the average CPU consumptions across all your clusters. What we can do is we can actually choose a functions to perform some aggregations. And in the aggregations, there's obviously an average function. And as you hover over the average function, you see the preview of what the function would look like when it's applied. By clicking the average functions, you can now see that the Wavefront has quickly calculated all the CPU matrices happening on all your cluster members and got the average value out of it. The chart is now much cleaner, and you can clearly see that during this time of the code deployment, you can see a rise of the CPU averages. And this may be yet another find in your day-to-day activities to tell your developers that CPU has been increased somewhat after this new code was deployed. Well, your developers might want to compare this with the yesterday's CPU averages. What you can do is you can actually create a shortened URL. This shortened URL format is available in all your chartings. So whatever you are seeing here can be expressed as this shortened URL. And what you can do is you can actually send this shortened URL instead of the picture or the captures or the reports. And your developers will simply open up their browser, copy and paste this shortened URL format, and they'll be able to see the same screen. Now, the developers want to compare this with yesterday's CPU averages very quickly to see how much CPU has increased or hasn't increased at all. They can actually create more queries to overlay on this existing queries. Create a new query, and they can use a lag feature to give for 1 day before snapshot of this particular CPU load that they're seeing right now. And I'll be sending this as a 1 day ago as a query. And just like that, a day ago query is easily overlaid with the today's CPU average. And you can see the difference that the yesterday's CPU was pretty nominal compared to the current CPU rise on this particular point of time of the deployment. Now you can recreate the shortened URL, and this has been just recreated, and send it back to the person who reported it. And they can actually go back, paste the same URL, and then they now see the same screen that the developer has been working to generate this new picture. Give them a better opportunity to share information that they found, and also hugely increase the collaborative nature of triaging the problem. This is one of the benefits of us having a query language, to give the flexibility to developers to create new queries and overlay new matrices, but also perform a lot of the aggregations and analytics. And also, lastly, share what they found out easily with their peer members on Wavefront. Okay, so let's go back to this average CPU kind of a picture here. I'm just going to remove so I want to talk about the scalability. So this CPU average is actually part of this whole CPU average in a yearly basis. So you are seeing a CPU rise in between this time of a period. If you see in a yearly fashion, this is what we have been seeing here. All the CPU clusters suddenly rose. About a couple of, 20 or 30 of them, and then quickly died off. But as you can see, Wavefront can span its metrics up to 18 months period of time, meaning that all your metrics data are going to be stored safely somewhere in Wavefront for a period of up to 18 months. This involves no downsizing or no resampling of the data. So you will not lose the full resolution of the data, and you'll be able to query the data as you would do up to the 18 months period of time. This gives user a greater chance to see a much bigger trends in their metrics. They can now see a yearly trend as a monthly trend to see how many servers have been spawned, or how many system has been gone up and down over a period of 1 year very quickly. Now, what I want to do is I want to actually aggregate the same data, but this time I'm going to do a different summarizations. These are all being aggregated as an average summarizations over a period of 1 year, meaning that these are actually the average representation of the CPU utilization. Now, sometimes we don't want averages. The averages actually hide a lot of facts. They hide a lot of outliers, and sometimes that's what we want to try to find out. What we can do is have a bit different summarization method without rewriting the code or the query to show some of the findings that didn't really exist in this picture. Let's say we want to check all the maximum CPU loads that happen across the full year on all their cluster members. Very easy. You can actually set this average to the max. And what the Wavefront can do is it will quickly identify all the max surges only happening across the whole year on all your clusters. Now the picture looks very different. It shows two huge surges that happen in November and also April on a particular host. And this is the same cluster host that we're seeing here. We can actually zoom in from this yearly picture to a very minute of the CPU, where the CPU surge actually happened very quickly within a couple of seconds, and see that this particular cluster host, the app server number 1 and 2B, was actually exhibiting a high CPU loads on a period between 635-ish to 643-ish. And just like that, from the yearly view, you can change the way you look to summarize your data. And in this case, we wanted to target on a max CPU consumptions. And we can drill down and get the exact time period without losing any resolutions in a very performant way, all being powered by Wavefront query language. And also, we can share this finding with your peers, just like we did in the last demo. The next demo is actually finding some of the anomalies using a feature called moving correlations. Now, there are many different type of things that you can do other than just looking at the screen and seeing the matrices and pointing out the matrices using your naked eye. That can be useful in some situations, I'm sure, but in many situations, the chances are you will be seeing a lot more matrices, tons of matrices that you can simply not manually see all the anomalies or all the problems on your way. Sometimes having automated alert capabilities like alerting using anomaly detection is very useful. Sometimes doing a moving correlation analysis is useful, but whatever that way is, Wavefront provides them all. In this particular examples, you see a dashboard which keeps track of a KPI, which is a transaction per second rate of your application server or running your applications. And you now see that there's a drop of your KPI, which is a problematic because this is probably going to be violating your SLAs. And you see that the alert has been generated by Wavefront. Transaction rates are too low. Now, you want to kind of take a look at some of the different ways that the Wavefront can do in viewing your transactions. Because we do not really remove or downsample any data, we can actually break down the data into many different filters or dimensions. So let me just go ahead and change this transaction per second and break it down by each customers. So each customers were sending some transactions to us, and as you can see, all the customers are kind of suffering and having a bad experience in running their transactions. So the problem is actually not coming from any of the customers by themselves. It's actually coming from within our own system. Now we can change this to monitor the application server. Per application servers, how well their behaviors are doing. And seeing here, we now know that out of about 20 different servers, there's only one bad behaving bug that's dropping down the whole transaction per second KPI. And we found the solution. We found the point where we can start investigating and finding out the cause of this. Now you can actually shut down this server and restart this server and hope that the server will behave better than used to be, but it might fall into the same situation. So having an investigation is very important in this case. And using the matrices, we can actually help users do that. Now, what I'm going to do is, because this is the server number 5, I'm going to change the perspective of my matrices that are collecting from the server number 1 to server number 5. And when I did it, Wavefront actually collects all the matrices that's coming from a server 5 here. And as you can see, the matrices are pretty messy because they range from the disk bytes read to request latencies to memory largest, CPU utilization, and all the gist of the matrices. We currently do not know which matrices to look for because they represent the whole health checks of the matrices that system is generating. Now, what we can do is we can actually use the moving correlations to use a known bad behavior, which is a transaction count that looks like this, right? So this is the same transaction count that we know that is a sign of a bad behavior. To run a correlations to see if among all those messy matrices that we are collecting from the app server number 5, will there be a similar looking pattern or similar looking metrics data that exhibited either a steep rising or steep declining of their values. And that's what the moving correlation does. The correlation function collects, calculates, and filters and displays only the one that may look relevant to the pattern that we are looking for. So we'll run the correlation, and Wavefront is actually running a moving correlation functions. And then it returns with a minimum set of matrices that are much more easier and easily discoverable. We have identified that the rate of the memory, the free memory, has dropped as the transaction rate dropped. We now have the log errors that's rising up, and we now have an increasing garbage collection count, steeply increasing as the transaction rate dropped. So by looking at these 3 key elements that are correlated to this bad behavior, we can have a deduction that because of the lack of memory or some sort of a memory leak or out of memory issues or memory faults, the garbage collection has been going up. And because the garbage collection has been going up on a JVM, it effectively halted the JVM's operation and then resulted in drop of the transaction count and also the increase of the log errors as shown here. So this is how effectively and very quickly Wavefront can resolve some of the situations by not having the users go to individual tools and collect the matrices one by one, maybe have a meeting with other admins or system admins to ask these kind of questions and get a holistic view very manually. We can actually do this without having to go to other tools, all on a single place on top of Wavefront, using the same query language and same visualization on an advanced analytics like correlations. So this is a very good example of how the Wavefront query language can actually help resolve the situations. It doesn't really tell you a lot of differences, but what we can do is we can also create an external linkages so that if you want to drill down into this log errors and see the exact log messages, you can actually have an external link to go to your Splunk environment. And the Splunk environment will have all the details of your errors and then it will tell in more details of where in which application that this error was coming from. But this is a nice way to have a Wavefront as a first pane of glass, first line of defense, so that rather than getting confused and going in spending too much time trying to figure out what really went wrong, you now have a better location or better answers to your question, the ultimate question of where do I start from? Where do I start looking for the problems from? The other examples are basically the customization ability of your dashboards. So we've seen some of the custom dashboards, and the beauty of the Wavefront is that you could actually create your very own customized dashboards to only see some of the things, some of the relevant things that you really need, rather than looking for those signs in many different places. So we have numerous ways to customize the dashboard. This is one of the examples of I created a dashboard where I'm showing you the Wavefront usage of how many sources are there, how many proxies are currently running, to some of the Linux hosts that I'm monitoring, to some of the VMware hosts that I'm monitoring, to Docker containers where it's running on top of the VMware, to Kubernetes where it is the Dockers are actually part of these Kubernetes, to a general applications like MySQL. Whatever the stack is, we can stack them up together and give you a holistic view or better view of what's everything is happening on at the same time. Another example is the plane spotter applications that we are running in a Kubernetes environment. So this is a really good example of how the customized dashboard can actually help you solve the problem a lot faster. So here, I'm actually looking at about a day's worth of all the metrics. And I have created this dashboard in such a way that I'm looking at from the application's perspective. The application, the plane spotter, is composed of series of engines web front end that handles the customer's web request. It also runs two versions of the databases. One is the Redis database, and the other one is a MySQL database running SQLs. And all of them are running as a containers or inside a Kubernetes pods. So I also overlaid the PKS, some of the PKS utilization metrics on top of my dashboard, right? These does not represent all the metrics, obviously, but these are some of the key metrics that I want to monitor all the time. So I have created this dashboard. Some of the examples of how effective this can be are as follows. I see immediately that there's a huge rise of the CPU metrics. And then the usage can easily be correlated visually. I can run the correlation, but it can easily be correlated that it is something running on top of the Redis. The Redis database patterns are matching with the CPU usages. So I know that the pod is running a version of Redis. And the pod name is ADSB sync, which means that there's some synchronization going on with the Redis with some external applications. And then this is causing some of the keys to be generated and also the command rates to go up. And that's consuming a lot of the CPUs on this pod. I do see that there's no user connection differences in a day, and there's a minimum set of CPU commands, the CRUD operation commands running against the MySQL. So that this is not user-induced operation, but actually a system-induced, some sort of a regular schedules to synchronize some of the database's data with the external system. And that can be something that can easily find out by laying out all the metrics coming from different stacks at the same time. Now, here's an interesting finding. I see that there are 3 color rises in our Kubernetes nodes in a PKS. It has been risen considerably high, so I want to zoom into that. I can drag and drop and get a much more kind of a clear picture in a better resolution, right? And I can run a sync time to see if any of the application activities coincide with these kind of activities here. And as you can see, there's actually not too many the client activities or command rates going up or down. So I know that this is not related to the SQLs or the Redis or even the web front end. It's something different. I want to investigate more, and what I can do from this dashboard is kind of drill in to the node CPU utilization, which displays the detailed chart from this dashboard to give me a more better pictures of it. Now, this doesn't really tell you too much about other things. So what I can do is I can actually try to find out which pod this is actually originating from, rather than just looking at the node perspective. So I'll create an additional query, and then turn on my query builder, and start typing in PKS heapster, and then from the node, I will be working on a pod container, and then get the CPU utilization and the usage rate of this particular pods, right? And immediately, I can actually see that when I align this closely with the right picture, the overlay between the node and the pod, and can see that from this picture, this node was actually running a instance pod of the Lacework data collector. So something of a Lacework agent was actually running and incurring a lot of CPU activities. This is pretty helpful information, as I can actually run multiple queries to correlate and see the overlays to better pinpoint which pod within this node was this running, and whether this is related to any of our plane spotter application. And in this case, certainly not. So just a quick example of how a customized dashboards and also combination of running a query on those dashboards can better pinpoint the exact location problems that we are seeing here. Another examples is the accurate alerting. So we have introduced a function called the Anomalous Detection function, which can automatically detect some of the patterns, abnormal patterns that wasn't there in the before. So what I mean is that the anomalous pattern actually learns the data anomaly by looking at the past behavior of certain matrices. And it can therefore automate a lot of the detection process because now you don't really have to assign certain thresholds or continuously modify a certain conditions to enhance your alerting. The alert function will simply learn from the past history and then give you alert based on that. You now have the CPU that has been going steadily and then suddenly dropped. And then at this point of time, it's kind of climbed up and then returning back to normal. If you were to detect each of the points, then previously what you should have done is to create a variance ratio or the difference of the CPUs and then calculate the percentages of the variances or the rate of the variances and then raise the alert based on that. Now with the introduction of the anomalous functions that you are seeing here and below here, you could actually skip all that and run a anomalous detection automatically, giving the anomalous automatically detecting where that matrix has fallen off, where that it has picked up, and then return back to normal. So these kind of anomalous function is very helpful when you do not want to calculate or create any specific conditions or the thresholds of your alerts. And it's what we call the advanced alerting or intelligent alerting, where now you can use this anomalous conditions to discover new anomalies without having you realize any of that. Some of the other features include histogram functions. So histogram functions are really useful when you have a very highly concentrated data that's coming from many different sources, which can be redundant or duplicated. A great example is when you have thousands of containers or microservices all try to emit the same matrices of transaction rate or the number of transactions. In that case, the Wavefront server cannot effectively collect all the matrices in high such detail, and the histogram can be a really handy tool for that. We have a dedicated port and dedicated data storing the histogram conditions. What's really great about the Wavefront histogram is that our data sampling samples all the data without putting into their buckets or bins before they arrive in the data. So you can have various ways to create the percentiles. In this case, the mean values are shown here that you can actually modify whether you want to see the 20% percentile and get the difference from your mean, or the 90% of the performance against your mean values, and etc. These are all possible because our histogram functions are very advanced and has a t-digestion algorithm that will be more accurate in determining the percentiles. And moreover, you are not fixed with certain preset number of the percentiles. You can have as many percentiles as you want, whether it's a 91, 93, or 97, etc. Other features are the application services. We have a distributed tracing as our newer feature. So here we have the applications where the applications are microservices that emit certain tracing informations in a distributed environment, because they run all in a very different places. But Wavefront now has the ability to collect those distributed tracing. And if you want to jump into some of the microservices, you now can see whether it's in a summarized view or the detailed view, or your activities, microservice activities. But at the same time, it can keep track of top fail request, top request, and now the slowest request, and present you an easy overview of the dashboard here. You can drill down into this and see some of the top running transactions per last hour, or maybe last 12 hours even. And you can see that the rate of the transaction that's happening, right? You can drill down into some of the erroneous ones. So in this case, this shopping orders had some errors, and then get a tracing of what were the critical path of this transaction calls. This was a makeshift, and how much time individual microservices within this big unit of microservice was spending much more time. And when did the error actually happen? So here, there's an error in the delivery on the last section of the post, and you can drill down. You know the exact URL of the microservices at the time of the fail, the error code, which was 400, and then you also know that the process is the beach shirts app number 26, which caused or which reported where this application error was coming from. So the distributed tracing, aside from the metrics monitoring, will greatly enhance the chance for our users to quickly pinpoint where the problem happened and how it happened without going too deep into each individual tools. So that's pretty much what I prepared for today's webinar session. Just to give you a brief summary before we move on to Q&A, the Wavefront is a SaaS-based metrics monitoring solution. It has 4 distinct characteristics of being scalable, highly available, at the same time giving a maximum flexibility of the users to self-service their metrics monitoring needs. It has a really greatly customizable dashboards that can really help the user experience. And also lastly, the intelligent alerting and forecasting features will allow you to automate some of your anomaly detections with a greater strength. And we have tons of new exciting integrations options, as well as a distributed tracing that will make the Wavefront solution even more powerful. So that is all I have for today. I would like to move into the Q&A right now. If you have any questions or anything that you want to get more details of, feel free to ask to the chatting window, and we'll start the Q&A from here. Caroline?
Yep. So I noticed a couple were coming in as we were doing the presentation. I'm looking through some of these here. Can you talk, there's questions, a couple questions kind of talking about Wavefront API, just kind of how you can, the REST API, what you can do with it. So if you could briefly discuss.
Sure, yeah. So we have a really good documentations within our UI to cover much of the details about the APIs and how it gets called. So in your Wavefront UI, on any of the UIs that I have opened up here, there's a little gearbox icon at the right top. And once you click it, there's a property picture, but there's actually an API documentation page. This is normally not available in our Docs Wavefront website, because this is actually a live API documentation that was generated using Swagger. So if you go and click this API doc, you will see all the publicly available REST endpoints that we expose today. For example, the dashboards. If you click the dashboard section, it expands and it shows you all the entry points or the REST endpoints. For example, if you click the dashboard here, this is actually used to get all the list of the dashboards that you have within your environment. And you have a sample schema that looks like this. And you can immediately try it out by clicking this button. When you click this button, what happens is that this particular endpoint operation is going to run. And it's going to give you back the response in JSON format. So it is actually kind of invoking this REST API services, and then it's showing the result in a response body, as well as the curl command that you can use to run this this particular REST command by yourself. So running this will give you the result and the data structure, right? So you can actually take a look and study, and also use to try out other things such as creating a dashboard using the API. So you just get the the dashboard information and post it here. Dashboard will be created. But at the same time, you can actually run a command on your console to do the same thing. So running this will actually give you the same response as this dashboard. So this is generally how you would kind of take a peek around on your APIs. And pretty much most of the APIs are exposed, other than some of the system ones. So basically what you can do on top of your dashboards, on top of your charts, can also be done via the APIs, such as event creation, the queries, the setting up the proxies or the sources or the users, and etc. So please go into this site if you have access to Wavefront, and you can then get access to all the APIs. Okay, hope this answers.
Let's see. And again, I just want to highlight, we do have a trial as well. You can see on the screen there, wavefront.com/signup. So you are able to, try some of these things you've seen for yourself as well. Looking through a couple more of these. Question about event baselining, how we do that.
We do a event baselining using our events, obviously. Our events are pretty simple. If you want to overlay some of the events, we have a query functions to call up and bring up the events. It's called the event. And you can, if you specified any names or any duration or the type or the tags of the event, we can actually call them and overlay on top of the charts, just as we did on this one. So we don't really have the events right now, but we can actually create events on that would appear here. All the events are kind of managed in our events page. So we do receive a lot of the different events happening, for example, on our Jira system or our Jenkins systems. It's all being powered by our event API. So chances are those systems are integrated with Wavefront. They send event messages, and then we receive and we overlay them on our charts or on our dashboards. So that's pretty much how we baseline it. The majority of the events are time-based. So we have a duration of the events, start and the end time. And if the time windows falls between that time, the events will be visible on your charts.
All right. I know we're getting close to time. So I know there's a few more questions on here. So what we can do is we can reach out to you with answers to your questions, the ones we weren't able to get to. Another place I would recommend looking is to go to our YouTube. We have a lot of new videos we just released and uploaded about some of our newer features regarding our AI Genie, as well as more distributed tracing videos. So I would recommend that you look there. And then the rest of the questions we didn't get to, we will have Howard reach out via email. But again, just thank you everyone for joining today. And we will be sending a recording of this out shortly. It'll probably come tomorrow in your inboxes, so look for that. And thank you, Howard. Appreciate your time this morning.
Okay. Thank you for having me, Caroline. And I hope this was very helpful for all of you. Just reach out to me if you have any questions, or reach out to our Slack channel. Thank you again.
Great. Thank you, everyone.
Okay. Bye.